Okay, in this video, we're going to be learning how to take the derivative function of a graph. So the derivative. It's probably spelled wrong. So the derivative of a function is the instantaneous slope at any point on a graph. So if this is x, and this is our graph, then this is point A, and this is f of x, right about here. And this is point B with point x plus h, because this area here is h. And then right across here is f of x plus h. So when we find the derivative, it's the slope at point A, this, or the slope at point B, this. They're different because it's a curve. So to find the derivative function of a graph, we're going to use the limit equation. So the limit equation is the limit as h approaches 0 is f of x plus h minus f of x over h. That is our limit equation. So we're going to practice this limit equation with the following problem. We're going to do x squared plus x. So x squared plus x, we're going to plug into the limit equation. So the limit as x approaches 0, as h approaches 0, my bad, we're going to plug in x of h for x. So the f of x of h, so x of h is going to go into this equation. So we're going to do x plus h squared plus x plus h minus x squared plus x all over h. So now we're going to simplify this. So this is going to simplify to x squared plus 2xh plus h squared. That's using distribution of polynomials, plus x plus h minus x squared. Distributing this negative to this x makes this a negative x all over h. So now we're going to cancel out what we can. So this negative x and this x will cancel out. So we can just scribble those out. And this negative x and this positive x will cancel out as well. So we are left with 2xh plus h squared plus h over h. So all these terms have an h in them, so we're going to factor out an h. So h, and then we're going to add 2x plus h plus 1 all over h. So this will help us cancel out here. So now our equation is 2x plus h plus 1, and our limit is as h approaches 0. So we're going to plug 0 in for h. So we get 2x plus 0 plus 1. And the f of x, the f prime of x, which is how you write the derivative function, is you write a little line that writes the prime of x. So f prime of x is equal to 2x plus 1. And we did that by using the limit function. So I'm going to give you 2 more problems that I want you to try on your own, and then I'll explain how to do them. So our first one is x cubed minus 3x, and x squared minus 5x. So I'm going to give you just a second to do that. Okay, so we're going to take the limit. So the limit as h approaches 0 is x plus h cubed minus 3x plus h minus x cubed minus 3x over h. So we're going to now simplify this equation. So it'll be x cubed plus 3x squared h plus 3x h squared plus h cubed minus 3x minus 3h minus 3x cubed minus plus 3x, because we're distributing this negative to this number, so now it is a negative. So all of this is over h squared. Over h, sorry. Now we're going to cross out like terms. So this negative x and this positive x cubed can be canceled out. And this 3x, sorry, that looks like a y. 3x and negative 3x can be canceled out. Now we're going to factor this remaining equation. We're going to factor out an h. So we're going to do that over here. Here, we can move this down a little bit. So h, and then we're going to do 3x squared, because we're factoring an h out of that one, plus h squared plus 3xh, sorry, I switched the order on those two, minus 3 over h. Those two cross out, and now we're going to plug in 0 for h, so h equals 0. So 3x squared plus 0 squared plus 3x 0 minus 3. This becomes 0, and this becomes 0. So 3x squared minus 3. F of x prime of x equals 3x squared minus 3. Okay, next problem. So the limit as h approaches 0 of x squared minus 5 is x plus h squared minus 5x plus h minus x squared minus 5x over h. And then here we are again, we're going to simplify it. So this ends up being x squared plus 2xh plus h squared minus 5x minus hx 5h minus x squared plus 5x, because we're distributing the negative, so that makes that a positive, all over h. Now we're going to cross out our like terms. So here we have a negative 5x and a positive 5x. These are going to cancel each other out. And then we have a negative x squared and a positive x squared, and these are going to cancel each other out. So you're left with 2xh plus h squared minus 5h over h. So these all have a h in them. So we're going to simplify this equation to x of 2x plus h minus 5 over h. So these cancel out, and we are left with 2x plus h minus 5. Plug in 0 for h. You get 2x plus 0 minus 5. So the f of x squared minus 5 is 2x minus 5. Okay, so the method of taking the limit is the long method. So I'm going to teach you guys a quick shortcut method of how to do this a little bit faster. So this is called the power rule. So the power rule comes with its own equation. So if f of x is equal to a of x to the power of n, then f prime of x is equal to a times n x to the power of n minus 1. So I'm going to show you how to do this on 3x squared minus 4x plus 8. So in this problem, we're going to multiply 2 times 3, which is 6x, and then 2 minus 1 is 1. So 1 minus, this x is to the power of 1, times 4 is negative 4, as it was. Because the x is now to the power of 0, we remove it. Now this 8 doesn't have a value of x next to it, meaning that x is 0. So 0 times 8 is 0. So we can, if it's a constant, the derivative, constant f prime of x equals 0. Always, all the time. So if you just have a constant value, it's 0. Okay, so I'm going to give you 2 more problems that you're going to use the power rule on to complete. So that's the ax of n and the ax to the power of n minus 1 way to do it. So here is 3 to the square root of x, 3 times the square root of x plus 2 over x, and x squared minus 4 over x squared. Okay, so I'm going to simplify this problem to 3x to the 1/2, because that's what the power of a square root is, plus 2x to the negative 1, because it puts it below. So 1/2 times 3 is 1.5. And then 1/2 minus 1 equals negative 1/2, plus 2x minus negative 1 times 2 is negative 2. So negative 2x, negative 1 minus 1 is negative 2. Now using this equation, so this is f of x, f prime of x equals this equation. So you could plug in any value. So if x were equal to 3, we can plug in 3 at this point. So 3 to the negative 1/2 is 1 over the square root of 3. So it would be 1.5 over the square root of 3 plus negative 2 over 9. So, because that's x squared. So this would be x to the negative, this would be the rate of change at x equals 3. Okay, here's our last problem. 2 times x, sorry, I'm going to simplify it. X squared minus 4, and this would be x to the negative 2. So then this problem, 2 times x to the power of 1, because 2 minus 1 is minus. Negative 2 times 8 is positive 8, so this becomes a plus sign. Positive 8x to the negative 3. So that is how you do the power rule. So that is how you take the derivative of a function to try and find the point at the instantaneous slope at any point on your graph. That's how you do it. Thanks for watching.